Next, we'll be moving on to conditional statements, which at their core are statements that change the path of our code depending on certain conditions. For the sake of keeping things simple, for this section, red lines will connote that our code will not be following the specific path, and green lines will mean that our code is following the path. The main type of conditional statement that programmers use is the if statement, and this will show up countless amounts of times in any program you write. It is as simple as it sounds. If some condition is true, and usually that condition will be enclosed by braces, then carry out the instructions located within the if statement's brackets. Else, do another thing. Now, brackets are used in most programming languages to indicate a segment of code which will run. It works like this. If the condition in parentheses is true, then all of the code contained within the brackets will run, and if the condition within the parentheses is not true, then it will skip over all of the statements within the brackets. A quick note is that while this is the case with most programming languages, some, like Python, use colons and whitespace to determine where a piece of code starts and ends. But for the sake of this series, we'll be using curly braces. Now, the condition within the parentheses can take on thousands of different forms, such as if the value of the string variable name is equal to Stephen, or if the player's score, stored in an int variable, is greater than 5. The list goes on and on. Each of these statements is evaluated as a boolean, which you will remember from when we talked about variables, is either true or false. If the boolean is true, we run the code inside the curly braces. If it's not, we pretend everything inside the curly braces never existed and move on with our code. The if statement comes with two more additional statements that can go with it, else if and else. Else if is a conditional statement used directly after an if statement, and carries out mainly the same function as an if statement. However, the else if statement will only be evaluated if the preceding if or the preceding else if statement is bypassed due to its condition being false. So we would run through it like so. If something is true, we would run the code inside of that statement's curly braces. Else, if that something is not true, but another statement inside of the parentheses is true, we would then run that code segment. And if neither of them are true, we would skip both segments of code and move on in our program. This can be a hard concept to wrap your head around, so let's do an example. If we had a program that evaluated the if statement if age is equal to 10, we could then have a statement under that which stated else if age is equal to 12. Now, if the age variable was 10, which we can see from the example that it is, then the code immediately following that conditional statement in the brackets would run. The else if statement we made will not even be tested, since we know that it is going to be false, and thus the print statement inside of that conditional statement's brackets will be ignored, and the code will move on to the rest of the program. Now, for example, let's say we change the age variable to be 12 instead of 10. Now, instead of the first conditional statement being true, it actually evaluates as false, since age is no longer equal to 10. So what we do now is first skip over the print statement, which prints out that age is 10, since it's not. And then we evaluate the else if statement. We check if age is equal to 12, which again it is. And so now we run all the code inside of that conditional statement before finally moving on to the rest of our program. So, as a review, we check the initial if statement. If it's good, then we run all of the code within that if statement's curly brackets and move on with our program. If the initial if statement is not true, we then move on to any else if statements and evaluate if those conditional statements are true. We can have as many else if statements as we want, although this could lead to clutter amongst your code, so we'll talk about some alternatives later to help this out. Now that takes care of the if-else statement, so now we'll move on to the else statement. The else statement once again comes after an if or an else if statement, and will carry out its instructions no matter what, as long as the preceding statement/statements are evaluated as false. If we went back to our previous program, we could add an else statement, which would only have the code in its brackets run if the age variable wasn't 10 or 12. This will catch all cases of the program that didn't fit into our parameters. It's good practice to always have an else statement at the end of your conditional statements to catch any weird cases that may come up in your program. Now remember back to the fact that we could have thousands of else if statements. After a while that can get pretty cluttered, and so another very useful conditional statement which helps circumnavigate this problem is a switch statement. A switch statement is functionally similar to many if and else if statements together. You write a switch statement in the form of switch variable, and then below that you write out how many cases the variable could be. For instance, if we wrote switch var, and then under it we could write out 5 cases that the variable var could be, and then the instructions listed under each case would be carried out if the var variable would be equal to that case. Now switch statements are different since instead of using brackets, they use a colon to signify the start of a set of instructions and a break statement to end them. This is very useful because you are able to essentially use many if and else if statements without having to write nearly as much. In switch statements, you just always have to remember to include a default case at the bottom of the expression to denote any and all cases that don't meet the above requirements. This simply catches all the inputs that don't fit within the program's main cases. It's very similar to an else case at the end of an if-else chain. Now, why are these statements so useful? Well, many times, programmers want their programs to function differently depending on different conditions. For instance, a program could function differently depending on the information that the user inputs, such as allowing a user to use a program or not use a program if they are above or below 18 years old, respectively. Or in, say, a video game, if a user's experience is above a certain threshold, we might want to give them harder opponents to battle. Another example could be a program which changes the color scheme depending on the time of day. Or even more simply, if a user presses a button that is meant to move on to another screen in an app, the programmer would only want that app to change screens if the user clicks that button. A program without conditional statements would do the same thing every time, and would be very primitive compared to one that can change depending on its conditions.